Good evening, children. Once again, let's move to a case study in physics, that is a part of science. And the chapter is light reflection and refraction. We have already discussed the three case studies also. So please like, share, and subscribe to your friends also. Uh, Again, I'm just welcoming to one mark solution. Now let us move on to the cases for discussing. So, first case. That means now it is first case. Already we have discussed three cases in this chapter, and you are familiar with these topics and the concept also. Again, I am telling that you have to understand the concept. Then only you can undergo any question. That means you can evaluate. That means you can read the questions and you will get the answer very clearly. So let us move on to this. And you can see a glass slab is there. That is PQRS, a glass slab, and a light is incident. And after that, a refraction will take place. Again, it is, what is it? It is emerging from this glass slab. That also you can see it, I think. So AO, it will be the incident ray, and OB is the refracted ray inside the glass slab. And from B to C, it is the emergent ray. Then here we can say angle of incidence, the normal, the angle between the normal and the incident ray. And here it is the angle of refraction. Angle of refraction means normal and the refracted ray. Again, you can see the angle of incidence in the second phase. And now we can call this angle, we can call it as angle of emergence. Now, one more thing you can see here, if you are producing AO, you can see that it is with dotted lines. It will be parallel to our emergent. If you are doing it, you can do it in the lab also. If you're, some of you have done it, I think. If you are doing it in the lab, if you are doing correct observation, if you are doing it, you will get parallel. That means the emergent ray and the incident ray will be parallel. And the perpendicular distance between these two, we can call it as lateral shift. Then one more thing I want to make it sure that if the light is passing, that means light flows from rarer medium to denser medium. That means from air to glass. Of course, all of you know that air is rarer medium, glass is denser medium. If it is passing from rarer to denser, what will happen? It will bend towards the normal. You can see that. If it is passing from denser to rarer, that means glass to air, we can say the angle of refraction, it is more, and the ray, that means refracted ray, will be bending away from the normal. From this difference, you can identify which is the medium, whether it is rarer or denser medium. Okay. Now let us just read it out. Ram placed a glass. One of the student, just we can call it as Ram. Ram placed a glass slab on a drawing sheet. We have to draw it in the drawing sheet and marked its boundary as PQRS. Then he removed the glass slab and drew a line AO, that is the incident ray, on the side PQ. He placed the glass slab again. For what purpose he placed there? Then only we will get the other rays. So he placed the glass slab in position, passed light from a laser. If you are putting the laser, it is just like a one light you can see, isn't it? It is moving like that. So in this manner, one torchlight, that means laser torch will be there. It is pointed one, so you can see that very clearly. You can see that from a laser torch through it along AO. He observed that the path of the light through the glass slab and marked the points O, B, C. All these points he has marked with this laser beam and marked the points O, B, and C. PQ is the surface of separation. You can see the PQ is the surface of separation between air and the glass, and RS is the surface of separation of glass and air. And some idea you got about the glass slab and the refraction, double refraction here occurs. Now we can go for the questions regarding this case study. First question we can say, where does the incident and emergent ray meet in above figure? In the above figure, where can it meet? You just see that two are parallel. So it will be meeting, sorry, it will be meeting where? No doubt here you can see inside the glass, infinity, above the glass slab, none of this. No doubt here you can say parallel rays will be meeting, meeting at infinity. So the option is B. Let us move on to the second question. Which of the greater optical density? Which of these are having more density? Optical density, not the mass density, it is optical density. If optical density is more, refractive index also will be more, the velocity will be less. So if it is air or glass or both glass and air, we have seen that when a rarer medium, that means the light passes from rarer to denser medium, what will happen? It bends towards the normal. So which is denser medium? We can say no doubt it is B, that is glass. So that is the option. Now let us move on to the third one. Is the angle of refraction greater or lower than the angle of incidence when it goes from glass to air? That you have to note it. Why? Because when it is passing from glass to air, the refracted ray will be bending away from the normal. That means the angle of refraction, you can see it will be more. That means the answer will be greater. A, option A, greater. Now let us move on to the fourth question. In the above figure, lateral displacement is mentioned by. I'll just show the figure once again. You can just find the answer from here. You can see that what is the lateral shift? You can see where it is. You can see that it is marked as CD, perpendicular distance between the incident ray produced and the emergent ray. BC is the emergent ray and AD is the incident ray produced. AO is incident ray and it is produced. So what is the answer? We'll just see that. Which are the options given here? Yes, AO, OB, BC and CD. No doubt it is answer is CD. Now let us move on to the fifth question. The perpendicular distance between the incident ray produced and the emergent ray is called. Just now we have mentioned the name of that. And we have just, yes, see that, which is that. So what is that? The perpendicular distance. That is very important. We can't take the distance between the incident ray produced and emergent ray simply. We have to take the perpendicular distance only. And we can call it as lateral shift. That is the option B. Thank you, children. Thank you for watching.